6 flashes of light erupted on the moon while 4 astronauts floated in total silence behind it, cut off from every other human being alive. No radio, no signal, no way home except the math. They were 252,000 miles from Earth, farther than any human has ever traveled, watching rocks slam into the lunar surface at 40,000 miles per hour. And when they came back around and saw what the far side actually looks like, what they described did not match a single photograph ever taken. The colors were wrong, the terrain was alien, and one astronaut said something that stopped mission control cold. Humans probably have not evolved to see what we are seeing. Tonight, we are going behind the moon. And what the Artemis II crew found there changes everything we thought we knew about our closest neighbor in space. If you enjoy our calm nighttime journeys, remember to like and subscribe. We highly encourage our community to discuss the video topics in the comments and react to other comments. It is the most fun when we share our thoughts. Now let us begin. Tonight we are going somewhere no human has gone in more than half a century. Not to the edge of the solar system, not to the surface of Mars. We are going to the moon. But not the moon you think you know. Not the pale silver disk you see when you look up on a clear night. Tonight we are going to the other side. The side that faces away from Earth. The side that no human eye had seen directly since 1972. And when the Artemis II crew swung around that far side on April 6, 2026, what they found did not match anything they had trained for. The colors were wrong, the terrain was alien, and while they floated in silence behind the moon, cut off from every other living soul on Earth, they watched rocks slam into the surface, hard enough to see the explosions from 4,000 miles away. 6 times during their flyby, pinpoints of light erupted on the lunar surface. 6 impacts, 6 detonations bright enough to be visible from the cabin of the Orion spacecraft, and nobody on Earth could reach them. Over the next 2 hours, we are going to follow the Artemis II mission from launch to lunar flyby to a solar eclipse that lasted nearly an hour. We will float behind the moon in total communications blackout. We will learn why the far side looks nothing like the near side and why that difference has baffled scientists for decades. We will watch an astronaut weep as he names a crater after the wife he lost. We will discover what keeps hitting the moon and why it matters for every future mission. We will learn what cosmic rays do to the human eye in deep space. And we will witness one of the most extraordinary sights any human being has ever seen. An eclipse viewed not from the ground, but from 4,000 miles above the lunar surface, where the sun disappeared behind a black orb and the corona wrapped around it like a ring of white fire. This is the story of what Artemis II saw behind the moon, and it begins with a flash. Chapter 1. 6 Flashes on a Dead World. April 6th, 2026, 8:35 p.m. Eastern Time. The sun has just slipped behind the moon. From the perspective of the Orion spacecraft, the entire lunar disk has gone dark. It hangs in front of the crew like a black marble, a perfect circle of nothingness rimmed by the ghostly white glow of the solar corona. The 4 astronauts aboard the spacecraft named Integrity are floating in their cabin roughly 4,000 miles above the surface. They are 2,756 miles from Earth. That is farther from home than any human being has ever traveled, farther than Apollo 13, farther than Apollo 8, farther than any person in the 300,000-year history of our species. And they are watching the moon die in the dark. Then it happens. A pinpoint of light erupts on the surface below. Brief, sharp, gone in less than a second. Commander Reid Wiseman sees it first. A flash on the darkened face of the moon. He calls it into mission control. Then another one. 2 impacts in rapid succession. Rocks from deep space slamming into the lunar surface at speeds exceeding 40,000 miles per hour, detonating on contact, and producing flashes bright enough to be seen by the naked eye from thousands of miles away. But Mission Control does not hear 2 of those reports, not right away. Because 2 of the 6 confirmed impact flashes occurred during the communications blackout, when the Orion spacecraft was behind the Moon, and every radio link to Earth had gone dead. Canadian astronaut Jeremy Hansen reported seeing 2 flashes during those 40 minutes of silence. He and the crew were the only witnesses. 4 human beings watching explosions on a dead world with no way to tell anyone. By the time the flyby ended, the crew had logged 6 confirmed impact flashes. NASA lunar science lead Kelsey Young was ecstatic. She reminded the crew that citizen scientists back on Earth had been monitoring the near side of the Moon at the same time. If the impact struck the near side, there was a chance that amateur astronomers had captured them too, allowing researchers to cross-check and verify the observations from multiple angles. It was the first time in history that human eyes in lunar space and telescopes on Earth might have observed the same impact events simultaneously, but the flashes were not a surprise, not to the scientists. What surprised them was the reaction of the crew, because the Moon, despite everything we were taught in school, is not a quiet place. It is a target range, a shooting gallery, a world with no atmosphere, no shield, no defense of any kind against the constant bombardment of the solar system. NASA's Meteoroid Environment Office has been watching the Moon since 2005, using twin telescopes at Marshall Space Flight Center in Alabama. In those years, they have logged over 443 candidate impact flash events. Across the Atlantic, the European Space Agency ran a program called NELIOTA, short for Near-Earth Objects, Lunar Impacts and Optical Transients, using a 1.2-meter telescope at the Cryoneri Observatory in Greece. Between 2017 and 2023, NELIOTA detected 192 validated lunar impact flashes, and those are just the ones we could see from Earth. The mathematics are staggering. According to the NELIOTA data, the entire lunar surface is struck by approximately 7.4 sporadic meteoroids per hour under normal conditions. During meteor showers, when Earth and the Moon pass through the debris trails of comets, that number rises to 12.6 impacts per hour. The rocks are mostly small. 75 to 80% have masses under 200 grams and radii under 3 centimeters. They are pebbles, gravel, the kind of debris you would kick aside on a hiking trail without a second thought. But those pebbles are moving at speeds between 20 and 72 kilometers per second. That is 45,000 to 160,000 miles per hour. At those velocities, a rock the size of a golf ball carries the energy of a small bomb. It slams into the surface, vaporizes itself and the soil around it, excavates a crater several feet across, and produces a flash of light that reaches temperatures between 2000 and 4500 Kelvin. Hot enough to melt steel, hot enough to glow. And because the Moon has no atmosphere, there is nothing to slow these projectiles down. On Earth, the vast majority of space debris burns up in the upper atmosphere. The shooting stars you see on a summer night are tiny fragments of rock and ice vaporizing from friction 60 miles above your head. They never reach the ground. On the Moon, every single one hits. Every grain of sand, every pebble, every boulder. There is no friction, no burn-up, no warning, just impact. The crew of Artemis II saw 6 of those impacts in a single 7-hour flyby. 6 flashes of light on a world that most people think of as dead and still. And the implications of those 6 flashes reach far beyond this single mission. Because NASA is not just visiting the Moon. NASA is planning to go back and stay. Artemis III will land astronauts on the lunar surface. Artemis IV will build a space station in lunar orbit. Future missions aim to establish a permanent human presence on the Moon, a base, a habitat, a foothold for the next era of exploration. And every single one of those missions will need to account for the fact that the Moon is constantly being hit. NELIOTA calculated the odds. A small structure on the lunar surface, something under 400 square meters, has a probability of 29 times 10 to the negative fifth power of being struck by a detectable meteoroid within a decade. That sounds tiny, but scale it up. A larger complex, covering 8,000 square meters, has a 0.9% chance of being hit in the worst-case scenario. An International Space Station-sized satellite in lunar orbit for 5 or more years carries a 1 to 2% probability of impact. And those numbers only account for the meteoroids large enough to be detected from Earth. The micrometeorites, the ones too small to produce a visible flash, are excluded from the calculation entirely. There are millions of them. And for an astronaut on the lunar surface doing a spacewalk, a centimeter-sized rock traveling at 40 kilometers per second is a projectile that no suit on Earth or off it is designed to stop. Victor Glover, the mission pilot and the first black astronaut to fly on a lunar mission, put it simply, "Humans probably have not evolved to see what we are seeing," he said. "It is truly hard to describe. It is amazing." He was talking about the eclipse. He was talking about the corona, but he could have been talking about everything the crew witnessed that day. The far side, the colors, the Terminator, the blackout, the explosions, the silence. All of it was beyond the scope of anything the human brain was built to process. And the flashes were not the only thing the crew saw that night. During those 40 minutes of communications blackout, when Orion disappeared behind the far side and every radio link to Earth went dead, the astronauts were completely alone. More alone than any human beings in history. And what they saw on the far side of the moon looked nothing like the world they had trained for. That silence, and what they witnessed inside it, is where we are going next. Chapter 2. The Blackout. At 6:44 p.m. Eastern Time, on April 6, 2026, the Orion spacecraft slipped behind the moon. One moment, the Deep Space Network, NASA's chain of 3 massive antenna stations in California, Spain, and Australia, was tracking the crew, receiving telemetry, monitoring their life support, listening to their voices. The next moment, silence. The moon's bulk blocked every radio signal, every data stream, every link between the crew and the rest of humanity. The screens in Mission Control at Johnson Space Center in Houston went dark. Flight Director Judd Freeling had warned everyone this was coming. He had told the team that physics would take over and that physics would absolutely get them back to the front side of the moon. But physics does not talk back. And for 40 minutes, nobody on Earth could do anything except wait. The crew had been briefed on this. They had trained for it. They knew the blackout was coming, and they knew it would last roughly 40 minutes. It was planned, expected, routine on paper. But there is a difference between knowing something intellectually and experiencing it with your body. And what the crew experienced during those 40 minutes was something that no amount of simulation could prepare them for. They experienced total isolation. Not the kind of isolation you feel when you drive into a dead zone on a country road and lose your cell signal. Not the kind you feel when you are alone in a house at night. This was absolute. There was no one to call, no one to reach, no backup channel, no emergency frequency, nothing. 4 human beings sealed inside a capsule the size of a large SUV, floating in the void behind the moon, with no line of sight to Earth, no line of sight to any satellite, no line of sight to any other human being alive or dead. They were on their own in the truest sense of the phrase. And during that silence, they saw Earth disappear. It is called Earthset, and it is exactly what it sounds like. Just as the sun rises and sets from our perspective on Earth, the Earth itself rises and sets from the perspective of someone in lunar orbit. As Orion swung behind the far side, the crew watched their home planet drop below the lunar horizon and vanish. One moment Earth was there, a bright blue marble hanging in the black. The next moment it was gone, hidden behind 4,000 miles of lunar rock. The only home every human being has ever known, swallowed by the edge of the moon. Christina Koch, mission specialist and the first woman to travel beyond Earth orbit, spoke about it afterward. She told President Trump that one of the biggest highlights of the entire trip was coming back from the far side of the moon and having the first glimpses of planet Earth again after being out of communication for about 45 minutes. "It really just reminds you what a special place we have," she said. That phrasing matters. She did not talk about the science. She did not talk about the observations. She talked about seeing Earth again, which means the 40 minutes without it were significant. The absence of Earth was not just visual, it was psychological. It was existential. For 40 minutes, the crew could not see their planet, could not hear their planet, could not confirm that their planet still existed except by trusting the math that said Orion would swing around and bring them back. During the blackout, the crew kept working. They continued their observations of the far side, photographing and describing terrain features that no human eye had ever directly seen. They watched for impact flashes on the darkened lunar surface, and Hansen reported seeing 2 of them, 2 explosions on the moon while they were cut off from every other member of the human species. They celebrated briefly. Jeremy Hansen had brought maple cream cookies from Canada, and the crew shared them in the dark, floating in microgravity behind the moon. Reid Wiseman called it a surreal moment. 4 people eating Canadian cookies in the silence of deep space, while rocks exploded on the world beneath them. This was not the first time astronauts had experienced this kind of blackout behind the moon. Every Apollo crew that orbited the moon went through the same communications loss. Apollo 8 in 1968 was the first. Jim Lovell, Frank Borman, and Bill Anders lost contact with Houston as they became the first humans to see the far side. They were alone behind the moon on Christmas Eve. The silence lasted about 45 minutes per orbit, and they orbited 10 times. Each time the signal cut out. Each time mission control waited. Apollo 13's blackout was worse. Not because the silence lasted longer, but because of the circumstances. The crew was in a crippled spacecraft after an oxygen tank explosion. They were using the moon's gravity to slingshot back to Earth. Their survival was uncertain. When they disappeared behind the moon, nobody in Houston knew if they would come back out the other side alive. They did, but the waiting was among the longest minutes in the history of the space program. Apollo 11, Apollo 12, Apollo 14 through 17. All of them experienced the same loss of signal behind the far side. Every crew that has ever gone to the moon has spent time in that silence, and every crew that will go in the future will experience it again because the physics have not changed. The moon still blocks radio waves. The far side still faces away from Earth. And until we build a relay satellite network around the moon, every spacecraft that swings behind it will go dark. The Artemis II blackout lasted from 6:44 to 7:24 p.m. 40 minutes. During that time, the spacecraft made its closest approach to the moon, just 4,067 miles above the surface. That is close enough that the moon filled the cabin windows. Close enough that the crew could see individual craters, ridges, and boulders. And at 7:07 p.m., still behind the moon and still in blackout, the crew reached their maximum distance from Earth, 252,756 miles, the farthest any human being has ever been from home. They broke the record in silence. No cheering from mission control, no live broadcast, no one watching. Just 4 people and the math. When Orion emerged from behind the moon at 7:24 p.m. and the Deep Space Network reacquired the signal, the crew had something to report beyond the impact flashes. They had seen the far side up close, and what they described forced scientists to reconsider what they thought they knew about the moon, because the far side of the moon does not look like the near side. It does not look like any photograph the crew had studied. The terrain is different, the colors are different, the texture is different. And the reason for that difference is one of the oldest and deepest mysteries in planetary science. The moon has 2 faces, and no one can fully explain why. Chapter 3. The two-faced moon. Look up at the moon on a clear night, and you will see a face you have known your entire life. The bright highlands, the dark splotches that ancient people called seas, the pattern that some cultures see as a rabbit, others as a face, others as a woman carrying sticks. It is familiar, comforting. The same side the moon has shown to Earth for billions of years because the moon is tidally locked, rotating at exactly the same rate it orbits Earth, so the same hemisphere always faces us. But there is another side. And the Artemis II crew saw it. As Orion swung around the far side, the astronauts photographed and described terrain that looked nothing like the near side. Christina Koch reported on the colors first. "The more I look at the moon," she said, "the browner and browner it looks." The crew described shades of brown and blue, greenish hues in the highlands, subtle variations in tone that revealed mineral composition in ways no satellite image had ever captured. They compared notes during shift changes and found they were seeing different things depending on the angle and lighting. This was exactly the kind of data NASA's science team wanted. Human eyes perceiving nuances that orbital cameras miss. But the most striking observation was not the colors. It was the absence. The far side has almost no Maria. Maria are the dark planes you see when you look at the near side from Earth. Those dark splotches are ancient lava flows, basalt that poured across the surface billions of years ago and hardened into smooth, dark sheets. The near side is 31% Maria. Almost a third of its surface is covered in these volcanic plains. The far side is less than 1%. It is a battered, ancient, crater-saturated landscape of pale highland rock, no lava plains, no dark seas, no familiar features, just craters on top of craters on top of craters, stretching to the horizon in every direction. A surface that has been hammered for 4.5 billion years without the volcanic resurfacing that smoothed out so much of the near side. The difference is not cosmetic, it runs deep, literally. The far side crust is up to 20 kilometers thicker than the near side crust. 20 kilometers of additional rock between the surface and the mantle below. That extra thickness meant that when asteroids slammed into the far side and cracked the crust, the magma beneath could not easily rise to the surface. The cracks did not go deep enough. The lava stayed underground. On the near side, the thinner crust cracked all the way through, and molten rock flooded the basins, creating the dark plains we see today. But why is the crust thicker on one side? This is where the mystery deepens and where some of the most exciting science of 2025 comes into play. The near side of the moon contains a geological region called the Procellarum, creep terrain. Creep stands for potassium, rare earth elements, and phosphorus. This region is enriched in radioactive elements, uranium, thorium, and potassium, elements that generate heat as they decay. For billions of years, this radioactive furnace drove volcanic activity on the near side. It kept the interior warm. It powered the eruptions that flooded the basins. It made the near side geologically active, while the far side sat cold and quiet. A 2025 study, published in the journal Nature by Park and colleagues, confirmed this interior temperature asymmetry using tidal response data. By measuring how the moon deforms slightly in response to the gravitational pull of the Earth, they determined that the near side mantle is measurably warmer than the far side mantle. The difference is baked into the moon's interior. It is not a surface effect. It goes all the way down. And in September of 2025, a study published in Nature Geoscience took the investigation even further. Researchers analyzed samples returned by China's Chang'e 6 mission, the first ever samples collected from the far side of the moon. The mission landed inside the South Pole Aitken Basin in June of 2024 and returned material to Earth for analysis. What they found was striking. The far side lava that did manage to reach the surface formed at approximately 1100 degrees Celsius. That is roughly 100 degrees cooler than the near side basalts. Professor Yang Li of University College London and Peking University called it the two-faced moon. The near side ran hot, the far side ran cold. And that temperature difference shaped everything. But how did this asymmetry begin in the first place? Why would one hemisphere of a world be enriched in radioactive elements while the other was not? The answer may trace back to the most violent event in the Moon's history, the event that created it. In November of 2025, a paper published in the journal Science by Hoppe and colleagues presented new evidence about Theia, the Mars-sized body that slammed into the proto-Earth roughly 4.5 billion years ago. That impact was so violent that it vaporized a significant portion of both bodies and launched a cloud of molten debris into orbit around the Earth. That debris coalesced and cooled and became the Moon. The new study traced Theia's origin to the inner solar system, based on isotopic analysis of lunar samples. During the Moon's early molten phase, when the entire body was a globe of magma called a magma ocean, the radioactive elements may have been concentrated on one side through a combination of tidal interactions with the nearby Earth and asymmetric cooling patterns. One hemisphere got the radioactive elements, the other did not. And from that moment forward, the Moon's fate was sealed. The side that got the uranium and thorium would run hot, erupt, resurface, and show the dark, smooth face we know today. The side that did not would stay cold, stay pale, stay battered, and wait 4.5 billion years for the first human eyes to see it. That chemical lottery, decided in the first few million years of the Moon's existence, dictated everything that followed. Which side got volcanoes? Which side stayed barren? Which side faces us? And which side hides in shadow? The crew of Artemis II was looking at the result of a coin flip that happened before life existed on Earth. And the data from Chang'e 6 revealed something else about the far side that carries enormous consequences for every future lunar mission. It is dry. Not just dry in the way a desert is dry. Dry in a way that almost defies measurement. The far side samples contained less than 2 micrograms of water per gram of rock. That is roughly 100 times less than the water found in near-side samples, which can contain up to 200 micrograms per gram. If you are planning to build a permanent base on the Moon, you need water. For drinking, for growing food, for manufacturing rocket fuel, and the far side has almost none. This discovery changes the calculus for lunar exploration. It means that future bases will need to be positioned near the poles, where permanently shadowed craters may harbor ice deposits, or on the near side, where the water content is higher. It means that the dream of a far-side observatory, shielded from Earth's radio interference and ideal for deep space astronomy, comes with a serious logistical problem. No water means no long-term habitation without constant resupply from Earth or from water deposits elsewhere on the Moon. The two-faced Moon is not just a scientific curiosity, it is a practical challenge. And the Artemis II crew saw it firsthand, from an angle and under lighting conditions that no camera had ever captured. They saw the ancient beaten surface of the far side. They saw the color differences that hint at mineral composition, and they brought back something no satellite can deliver, the perspective of a trained human brain processing a visual experience in real time. But the moment that stayed with many of them longest was not the far side. It was what they saw when they came back around. When Orion emerged from behind the Moon and the crew looked out the window and saw something rising above the lunar horizon. Something blue and white and impossibly fragile. Earth, coming back into view after 40 minutes of darkness. Chapter 4, Earthrise Again. At 7:24 p.m. Eastern Time on April 6, 2026, Orion emerged from behind the Moon. The Deep Space Network reacquired the signal. Screens lit up in mission control. Voices returned. Data began streaming. And outside the windows of the spacecraft, the crew watched Earth rise above the lunar horizon. It was not the first time humans had witnessed Earthrise. But it was the first time in more than 53 years, and it was the first time from this particular angle, at this particular altitude, under these particular conditions. Orion was farther from the Moon and on a different trajectory than any Apollo spacecraft had flown. The perspective was unique. Earth and Moon in the same frame, seen from a vantage point that had never existed before in human history. Koch's first message, after communications were restored, spoke directly to the power of the moment. She described the importance of coming back from the far side of the Moon and seeing Earth again. "It really just reminds you what a special place we have," she said. After 40 minutes of silence and darkness, the sight of home was overwhelming. There is a reason Earthrise hits so hard, and the history of that reason begins on Christmas Eve, 1968. Apollo 8 was humanity's first mission to the Moon, not to land, just to orbit. To go there, circle it 10 times, and come home. The crew was Frank Borman, Jim Lovell, and Bill Anders. They launched on December 21st and reached lunar orbit on December 24th. On their fourth orbit, as the spacecraft came around the far side and the Moon's horizon swept into view, Bill Anders looked out the window and saw something that stopped him cold. Earth was rising above the edge of the Moon, blue and white against the absolute black of space, hanging above the barren grey lunar surface. He grabbed a camera. The first shot was black and white. He swapped to color film. He took the photograph that would become the most famous image in the history of exploration. That photograph, Earthrise, is a color image of our planet rising above the lifeless grey curve of the Moon. It was the first time a human being had seen the Earth from this distance and this angle, and it was the first time anyone had photographed it in color from beyond Earth orbit. The image was credited with helping to catalyze the environmental movement. Nature photographer Galen Rowell called it the most influential environmental photograph ever taken. Time magazine included it in their list of the 100 most influential photographs in history. Bill Anders himself said it undercut his religious beliefs. The paradox was clear. We went to the Moon to explore the Moon, and what we discovered was Earth. The Apollo 8 Earthrise became a cultural touchstone. It showed humanity its own fragility in a way no speech or statistic could. The borders were invisible. The wars were invisible. The divisions, the politics, the arguments that consumed the daily news, none of them were visible from the Moon. Just a small, bright sphere alone in the dark, the only known home of every living thing. 58 years later, the Artemis II crew experienced the same shift. Victor Glover, the mission pilot, described it during a broadcast from the spacecraft. "Trust us," he said. "You look amazing. You look beautiful. You also look like one thing. Homo sapiens is all of us, no matter where you are from or what you look like. We are all one people." Jeremy Hansen, the Canadian astronaut, said it more simply. "Right away, you are humbled. The fact that 4 of us get to be out here just brings you to your knees." Scientists and psychologists have a name for this shift. It is called the overview effect. The term was coined by space philosopher Frank White in 1987 to describe the cognitive shift that astronauts experience when they see Earth from space. It is not just awe, though awe is part of it. It is a fundamental change in perspective. The borders disappear, the conflicts shrink, the planet looks like what it is, a single system, a single organism, a single home, shared by everything alive. Astronauts who experience the overview effect often describe it as life-changing. They say it stays with them. They say they never see the world the same way again. The Apollo 8 crew experienced it first. The Artemis II crew is experiencing it now, and if humanity continues to go to the Moon and beyond, more and more people will experience it in the years ahead. There is an argument to be made that this psychological transformation is not just a byproduct of space travel. It may be one of the most important reasons to go, not for the science, not for the resources, not for the geopolitics, but for the perspective, for the reminder that down here, on the surface, we are all standing on the same rock. The crew carried something with them, that made the connection to Apollo 8 tangible. Before the mission, they had been given the original Apollo 8 silk mission patch that had flown with Jim Lovell to the moon in 1968. They brought it aboard Orion and showed it off during the flyby. The patch had traveled to the moon twice now, once in 1968 and once in 2026, carried by different hands but on the same journey. And Lovell himself had one final connection to make. Just 2 months before his death, in August of 2025, at the age of 97, Jim Lovell recorded a wake-up message for the Artemis II crew. On the morning of the flyby, Mission Control beamed it up to the spacecraft. "Hello, Artemis II," Lovell said. "This is Apollo astronaut Jim Lovell. Welcome to my old neighborhood. It is a historic day, and I know how busy you will be, but do not forget to enjoy the view." The crew listened to the voice of a man who had orbited the moon on Christmas Eve, 1968, and nearly died trying to get back from it in 1970. A man who had seen Earthrise with his own eyes and lived another 57 years with the memory. A man who understood what the Artemis II crew was about to experience because he had experienced it first, and who wanted them to know, above all else, to enjoy the view. Wiseman's response was quiet. "It is just a real honor to have that on board with us," he said. "Let us go, have a great day." And then they got to work. Because while the overview effect was transforming their perspective, NASA's science team was fixated on something else entirely. The colors the crew had been reporting from the lunar surface. Browns, blues, greens, shades that do not appear in satellite images. What were the astronauts seeing that decades of orbital cameras had been missing? And why did NASA specifically design this mission to put human eyes above the moon instead of sending another robot? The answer goes to the heart of why we send people into space at all, and it begins with a sandbox. Chapter 5. What human eyes see that cameras cannot. Artemis II had 10 science objectives for the lunar flyby. One of the most important had nothing to do with instruments, sensors, or spectroscopes. It had to do with eyeballs. Specifically, it had to do with what the human eye can perceive that no satellite camera can replicate. Kelsey Young, the Artemis II lunar science lead, explained it before the flyby. "The human eye," she said, "especially when it is connected to a well-trained brain, is capable of just in literally the blink of an eye, making nuanced color observations." That sentence is deceptively simple. It contains the entire argument for sending humans to the moon instead of another robot. Here is the problem. Satellites, like the Lunar Reconnaissance Orbiter, have mapped the moon in extraordinary detail since 2009. We have high-resolution images of nearly every square meter of the lunar surface. We know the topography. We know the mineral composition in broad strokes. We can measure elevation, crater depth, shadow length, and albedo from orbit with precision that would have astounded the Apollo generation. But those images are captured in specific wavelength bands. The camera records light at fixed frequencies, like playing a piano with only certain keys available. The human eye does not work that way. It perceives a continuous spectrum. It can detect subtle gradations of color that fall between the wavelength bands a satellite is designed to measure. And crucially, the human eye adapts in real time to changing lighting conditions. As Orion moved across the lunar surface, the angle of illumination shifted constantly. The same crater would look different from one minute to the next as the sun's light hit it at a new angle. Young used an analogy to explain this. "Think of a sandbox," she said. "Change the angle of light on sand and you either see color and albedo or you see topography and morphology. You can tell whether the surface is rough or smooth, red or gray, reflective or dull, depending entirely on where the light is coming from. An orbiting satellite captures the surface under one set of lighting conditions per pass." The Artemis II crew saw the same features under continuously changing illumination, and their brains processed the differences instantly. The crew worked in pairs. 2 astronauts would float to the cabin windows, and observed the surface for 55 to 85 minutes, while the other two communicated with mission control, exercised, or ate. Then they switched. Reid Wiseman and Jeremy Hansen took the first shift. Christina Koch and Victor Glover took the second. Each pair described what they saw in real time, narrating their observations to the science team in Houston's science evaluation room. And here is where it gets charming. To keep their eyes dark adapted so they could perceive subtle color differences on the surface, the crew improvised. They draped a T-shirt over one of the cabin windows as a shroud to block stray light from inside the spacecraft. It worked, mostly. The T-shirt caused condensation problems, and they had to use a condensation hose to dry things up. Glover noted that switching between the dark cabin, his dim tablet screen, and the bright lunar surface was extremely taxing on his eyes. "This is a very taxing event on the eyes," he said. "As soon as I look back into the cabin after looking out the window, I can feel my eyes adjusting." The human factors of doing science in a tiny capsule 250,000 miles from home are real and messy and completely absent from robotic missions. NASA scientists had prepared approximately 35 geological features for the crew to observe and photograph. The targets had been loaded onto portable computer devices that the crew carried with them, custom-built software developed by the crew lunar observations team. The list included some of the most scientifically significant features visible during the flyby. The Oriental Basin was the primary target, a nearly 600-mile-wide impact crater straddling the near and far sides of the Moon. Oriental is 3.8 billion years old and retains dramatic concentric ring structures from the collision that created it. It would be fully illuminated and visible as Orion approached. The crew would observe it from multiple angles as they passed, giving them a three-dimensional sense of its structure through parallax, something no single orbital photograph can provide. Hertzsprung crater was another key target, a nearly 400-mile-wide basin on the far side. Hertzsprung is older and far more degraded than Oriental. Comparing the two craters side by side gives scientists a time-lapse of how lunar features evolve over billions of years. Hertzsprung's rings have been battered and softened by subsequent impacts. Orientale's rings are still sharp and dramatic. The contrast is a visual record of geological time on a world without weather or plate tectonics. The Glushko crater, 27 miles wide and known for its striking white ray streaks that extend over 500 miles across the surface, was on the list. So was the Reiner Gamma swirl, one of the most mysterious features on the Moon, an unexplained bright surface marking shaped like a tadpole that has baffled scientists since the 1600s. The crew also observed the Apollo 12 and 14 landing sites from above, seeing the terrain where humans had once walked from a perspective those earlier astronauts never had. And then there were the targets the crew was not expecting to feel emotional about. While scanning the surface with their cameras and naked eyes, they identified two small, previously unnamed craters. What happened next became the most human moment of the entire mission. Koch summed up the observing experience in a way that captured both the science and the emotion. At one point towards the end of my time in Window 3, she said, "I just had an overwhelming sense of being moved by looking at the Moon. That is the data point no satellite can return." The emotional response of a trained scientist to the raw visual experience of seeing another world up close with her own eyes. It is subjective, it is unquantifiable, and it is irreplaceable. After the flyby, Young radioed up to the crew one final time. "I cannot say enough how much science we have already learned," she said, "and how much inspiration you have provided to our entire team, the lunar science community, and the entire world with what you were able to bring today. You really brought the Moon closer for us today." That phrase, "you brought the Moon closer," is the answer to why we send humans. Robots collect data. Humans collect meaning. And sometimes the meaning is what matters more. The crew had one more act of meaning to deliver before the flyby ended. And it began with two small craters and a name that no one in Mission Control was expecting to hear. Chapter 6. Carol. Shortly after breaking the Apollo 13 distance record, while the crew was still working through their observation targets, Jeremy Hansen took the microphone. His voice was steady at first, professional, the kind of measured calm that astronauts are trained to maintain during live broadcasts. But what he was about to say had nothing to do with science objectives or flight operations. "A number of years ago we started this journey," Hansen said, "and in our close-knit astronaut family, we lost a loved one." He paused. Her name was Carol, the spouse of Reid, the mother of Katie and Ellie. Carol Taylor Wiseman was a neonatal intensive care nurse. She spent her career in hospitals helping the smallest and most fragile human beings survive their first days of life. She worked at the Children's Hospital of the King's Daughters in Norfolk, Virginia, and later as a school nurse in Maryland and Texas, moving wherever her husband's career with NASA took them. She was born in Virginia Beach and graduated from Virginia Commonwealth University. She was 46 years old when she died of cancer in 2020. Commander Reid Wiseman has been raising their two daughters alone since. Hansen continued, "While scanning the lunar surface that morning with their naked eyes and through telephoto lenses, the crew had identified two relatively fresh craters that had never been named. Fresh on the moon does not mean new by human standards. It means the craters still show bright ejecta that has not yet been darkened by billions of years of space weathering. They stand out against the older, darker surface like white spots on grey paper. The first crater, located just northwest of the Orientale Basin, the crew wanted to name Integrity after their spacecraft. The name embodied the foundation of trust, respect, candor, and humility that had defined their years of training and the mission itself. The second crater sat on the boundary between the near and far sides of the moon, near the Glushko crater, on the same latitude as the Ohm crater. It was a bright spot, visible from Earth at certain points during the moon's transit. Hansen described its location and then said the words that stopped Mission Control cold. "It is a bright spot on the moon, and we would like to call it Carol." As he spoke, Wiseman reached over and put his hand on Hansen's shoulder. His eyes were wet. He pressed his lips together and nodded. Then the two men embraced. It was not a formal handshake or a pat on the back. It was a real hug. The kind of hug that happens when grief and love and distance collide in a single moment. And then Koch and Glover joined them. All four astronauts pulled together in a floating embrace, wiping tears, holding each other in silence, 250,000 miles from home. Mission Control in Houston went quiet. The science team watched. The flight controllers watched. The families in the viewing gallery watched. Nobody spoke. The moment belonged to the crew and to a woman who was not there. Carol Wiseman did not get to see her husband launch. She did not get to watch him fly to the moon. She did not get to hear him describe the far side or the impact flashes or the eclipse. But from now on, if the International Astronomical Union approves the name, there will be a bright spot on the moon called Carol, a spot visible from Earth. A spot their daughters can look up and find on a clear night and know their mother's name is written on another world. The internet responded the way the internet sometimes does when something real breaks through the noise. One commenter wrote, "Sounds like Carol was loved to the moon and back, literally." Another said, "Her babies can look to the night sky and see their mum." A third wrote, "Find yourself a man who will fly to the moon to honor your life by naming a lunar crater after you." The names will be formally submitted to the International Astronomical Union after the mission concludes. This moment matters for reasons beyond the personal. It matters because it is the argument for sending humans into space distilled into a single act. Robots do not name craters after dead wives. Robots do not weep. Robots do not float in a group hug while tears cling to their cheeks in microgravity. The emotional resonance of Artemis II is not a byproduct of the science. In many ways, it is the science. It is what makes the public care. It is what justifies the billions of dollars. It is what turns a flyby into a cultural event that billions of people around the world follow in real time. Numbers and data fill journals. Moments like this fill hearts, and hearts are what fund the next mission. There is a deeper layer here too. NASA's biography of Wiseman notes that he considers his time as an only parent the most rewarding phase of his life. He did not retreat from the astronaut corps after losing his wife. He trained harder. He prepared. He flew. And when he got to the moon, the first thing he did with the freedom to name a landmark was honor the woman he lost. That is not just emotion. That is character. And character cannot be uploaded to a satellite. Jim Lovell understood this. The Apollo 8 and 13 astronaut who recorded the wake-up message for the Artemis II crew just 2 months before his death at 97, Lovell was the emotional bridge between the Apollo and Artemis eras. He had orbited the moon at Christmas. He had survived the near-fatal Apollo 13 emergency. He had seen Earthrise with his own eyes and carried the memory for 57 years. His message to the crew, "Do not forget to enjoy the view," was not small talk. It was wisdom earned across a lifetime of distance from Earth. Enjoy the view, because the view changes you. And sometimes, as the Carol moment proved, the change is the whole point. Koch was asked after the flyby to describe the mission in one word. She did not say historic. She did not say scientific. She did not say record-breaking. She said humility. The crew was back at the windows now. The observation period was nearing its end. And while the world was still absorbing the Carol moment, Victor Glover was seeing something on the surface that would shift the conversation from emotion back to wonder. The lunar terminator, the line between light and dark on the moon's surface, was revealing structures that looked like nothing in any satellite image ever taken. He called it magic. And what he described next would force scientists to reconsider what they thought they knew about the lunar surface. Chapter 7. The Terminator. The terminator is a line, not a political boundary, not a geographic feature, a line of light. It is the dividing edge between the illuminated and dark sides of the moon, where sunlight ends and shadow begins. From Earth, the terminator looks like a smooth curve sweeping across the lunar disk. From 4,000 miles above the surface, it looks like the edge of a world being swallowed by darkness. Victor Glover became obsessed with it. "I wish I had some more time to just sit here and describe what I am seeing," he radioed to Mission Control. "But the Terminator right now is just fantastic. It is the most rugged that I have seen it from a lighting perspective. There are little islands. There are islands of terrain out there that are completely surrounded by darkness, which indicates some real variation in terrain." Jeremy Hansen added his own description. "When you look at the Terminator," he said, "it is just like impossibly rugged, and it reminds you that the whole far side is that way." What the crew was seeing is a phenomenon that photographers and scientists understand well, but that most people have never thought about. At the Terminator, the sun sits right on the horizon from the perspective of the lunar surface. The light comes in at an extreme angle, almost parallel to the ground. When light strikes a surface at that angle, it casts enormously long shadows. Every ridge, every hill, every crater rim throws a shadow that stretches across the landscape like a finger pointing away from the sun. Features that would be invisible in overhead sunlight suddenly leap out of the surface in three-dimensional relief. This is why human eyes at this particular viewing angle see things that satellites miss. Orbital cameras photograph the moon from directly above. From that perspective, the sun lights the surface more or less evenly, and small features cast short shadows that can be lost in the resolution of the image. But from the Terminator angle, from the side, the long shadows expose micro-ridges, subtle fractures, ancient collapsed lava tubes, and tiny elevation changes that would otherwise be invisible. The Terminator is a revealer. It strips away the moon's smooth appearance and shows you what is actually there. And what is actually there is chaos. Glover described islands of light surrounded by complete darkness. These are mountain peaks and crater rims that catch the last rays of sunlight, while the valleys around them have already fallen into night. The effect creates a landscape that looks shattered, broken, alien. Glover said it looked like he had gone science fiction. After all of the amazing sights that we saw earlier, he told Mission Control, we just went sci-fi. Koch added another observation that carried scientific weight. She described the bright young craters that stood out against the older surface. What it really looks like, she said, is a lampshade with tiny pinprick holes and a light shining through. They are so bright compared to the rest of the moon. Those bright craters are geologically young. Their ejecta, the material blasted out during the impact that formed them, has not yet been darkened by space weathering. On the moon, space weathering is a slow process where solar wind particles and micrometeorite impacts gradually darken and redden the surface over millions of years. Fresh craters have bright white ejecta that slowly fades to match the surrounding terrain. The distribution of these bright craters tells scientists about recent impact rates, how many there are, where they are concentrated, and how quickly they darken all feed into models of how the lunar surface evolves over time. And then Glover reported something that caught even the science team off guard. Some mountain peaks near the Terminator were so bright that they looked as though they were covered in snow. Of course, it was not snow. The moon has no water on its surface in liquid or solid form, in quantities visible to the eye. What Glover was seeing was fresh, unweathered rock, possibly plagioclase-rich highland material, reflecting sunlight at a low angle with extraordinary brilliance. The whiteness of the peaks against the black shadow of the valleys created a visual contrast so extreme that it resembled a snow-covered mountain range on Earth. This observation matters because it reveals how dramatically viewing geometry affects what the moon looks like. Every photograph you have ever seen of the moon was taken from one angle under one set of lighting conditions. The orbital cameras that have mapped the surface captured it from above. The Apollo astronauts who orbited the moon saw it from 60 miles up under different solar illumination than the Artemis II crew experienced. Glover and his crewmates saw the moon from 4,000 miles above at an angle and under lighting conditions no camera had ever captured. And what they described did not match the photographs. This is the value of human observation. Not that human eyes are better than cameras in some absolute sense. They are not. Cameras capture more wavelengths, record data with perfect consistency, and never get tired. But human eyes are connected to human brains, and human brains are pattern recognition machines that have been refined by hundreds of millions of years of evolution. A trained geologist looking at a landscape under changing illumination can spot anomalies, connections, and features that a camera image, no matter how high resolution, might not reveal. And more importantly, a human can describe what they see in real time, adjusting their language, their focus, and their attention based on what surprises them. Glover was not reading from a script when he described the Terminator. He was reacting, and his reactions told the science team things they did not know to ask about. Kelsey Young, the Artemis science lead, responded to Glover's Terminator description with undisguised excitement. "Oh my gosh," she radioed back. "That was an amazing picture you just painted." I glanced over at the science evaluation room video and I literally saw fist pumps in the air. Those types of observations are things that humans are uniquely able to contribute. The Terminator also revealed something about the moon that connects to the broader story of this documentary. The long shadows showed just how thoroughly cratered the far side is. Every square meter of the surface bears the scars of impact. The Terminator made those scars visible in a way that flat lighting cannot. And the question that emerges from that relentless bombardment is both scientific and practical. What keeps hitting the moon? How often does it happen? And what does it mean for the humans NASA plans to send back to the surface? 6 impact flashes during a single 7-hour flyby is a significant number. The crew saw rocks exploding on the moon in real time. And The mathematics behind those explosions, the frequency, the velocity, the energy, are not reassuring for anyone planning to spend weeks or months on the surface. That is where we are going next. Into the numbers, into the hazard, into the uncomfortable reality that the moon is not just beautiful, it is dangerous. Chapter 8. What keeps hitting the moon? The moon has no atmosphere. That single fact changes everything about what it means to exist on its surface. On Earth, we live at the bottom of an ocean of air roughly 60 miles deep. That air is our shield. Every day, roughly 48 tons of space debris enters Earth's atmosphere. Tiny fragments of rock, ice, dust, and metal left behind by comets and asteroids. Almost all of it burns up. The friction of atmospheric entry heats these fragments to thousands of degrees, and they vaporize long before they reach the ground. We see them as shooting stars, streaks of light on a summer night, beautiful and harmless. On the moon, none of that happens. There is no air, no friction, no burn-up. Every single piece of debris that crosses the moon's path hits the surface at full speed. A grain of sand traveling at 50,000 miles per hour does not slow down, it does not glow, it does not announce itself. It arrives and detonates on contact, excavating a tiny crater and releasing a flash of energy. Scale that up to a pebble, a rock, a boulder, and you get impacts that can be seen from Earth. The meteoroids that strike the moon come from multiple sources. The majority are sporadic, meaning they are part of the general background debris scattered throughout the inner solar system. These are fragments of comets that have broken apart over millions of years, chips of asteroids that have collided and shattered, dust that has drifted through the solar system since its formation. They arrive from all directions at all times, a constant drizzle of destruction. The second source is periodic. Several times a year, Earth and the moon pass through the debris trails of specific comets. These are the meteor showers that stargazers look forward to. The Perseids in August, debris from comet Swift-Tuttle. The Geminids in December, debris from asteroid Phaethon. The Leonids in November, debris from comet Tempel-Tuttle. When the moon passes through these streams, the impact rate spikes, more rocks hit, more flashes appear. The bombardment intensifies for a few days and then subsides. NASA's Meteoroid Environment Office at Marshall Space Flight Center in Huntsville, Alabama, has been systematically monitoring the moon for impact flashes since 2005. Using twin 14-inch telescopes, the team records video of the moon's night side and scans for brief flashes of light. Over more than 2 decades, they have logged over 443 candidate impact flash events. Each flash represents a rock from space detonating on the lunar surface, hard enough to produce visible light from 240,000 miles away. Across the Atlantic, the European Space Agency funded the Neliota program at the National Observatory of Athens in Greece. Using a larger 1.2-meter telescope at the Creoneri Observatory, Neliota detected 192 validated lunar impact flashes between February of 2017 and August of 2023. The program became the largest study of asteroid collisions with the moon ever conducted. And in August of 2025, a new 3-year observing campaign began, extending the monitoring into the Artemis era. The Neliota data paints a detailed picture of what is hitting the moon and how hard. The meteoroids range in mass from less than 1 gram to roughly 8 kilograms. Their sizes span from about 1 centimeter to 20 centimeters in radius. 75 to 80% of the detected impactors have masses under 200 grams and radii under 3 centimeters. These are small rocks, pebbles, and gravel, but they are moving at velocities between 20 and 72 kilometers per second. At the upper end of that range, a rock the size of a marble is traveling at more than 160,000 miles per hour. The kinetic energy at those speeds is enormous. A 5-kilogram meteoroid, about the weight of a bag of flour. Hitting the moon at average speed would excavate a crater roughly 30 feet across. The impact would generate temperatures between 2000 and 4500 Kelvin. For reference, the surface of the Sun is approximately 5800 Kelvin. These impacts are briefly almost as hot as a star. The frequency is relentless. Neliotta calculated that the entire lunar surface is struck by approximately 7.4 sporadic meteoroids per hour under normal conditions. During strong meteor showers, that rate rises to 12.6 per hour. Every hour, every day, every year, for 4.5 billion years. This is why the moon looks the way it does. This is why every square meter of its surface is cratered. The moon is not a world that was once bombarded and then left in peace. It is a world that is still being bombarded right now. The Artemis II crew saw 6 impact flashes during their 7-hour flyby. Kelsey Young noted that because the impacts occurred on the near side of the moon, citizen scientists on Earth may have been monitoring the same region simultaneously. The Unistellar Citizen Science Network had organized amateur astronomers to watch the moon for impact flashes during the Artemis II flyby. If any of the citizen observers recorded the same flashes the crew saw, the cross-verification would be scientifically valuable, allowing researchers to triangulate the exact location and energy of each impact from multiple perspectives. Apollo astronauts also saw impact flashes during missions in the 1960s and 70s. At least 3 were reported across the program, but the technology to correlate those observations did not exist at the time. The observations were noted in mission logs and largely forgotten. Artemis II represents the first time that human observations of lunar impacts from cislunar space can be directly compared with ground-based monitoring data. The crew's reports will feed directly into meteoroid hazard models for every mission that follows, and those hazard models matter, because NASA is not just flying by the moon, NASA is going back to the surface. Artemis III will land astronauts near the lunar South Pole. Artemis IV will build the Lunar Gateway, a space station in orbit around the moon. Future missions envision permanent habitats, research stations, and eventually a sustained human presence. Every one of those plans must account for the bombardment. Neliotta calculated the probabilities. A small lunar structure covering less than 400 square meters has a probability of 29 times 10 to the negative 5th power of being struck by a detectable meteoroid within a decade. Tiny, almost negligible, but scale it up. A larger complex or cluster of structures covering 8,000 square meters has a 0.9% chance of being hit in the worst-case scenario when both validated and suspected impact events are factored in. And an ISS-sized satellite in lunar orbit for 5 or more years carries a 1 to 2% probability of meteoroid impact. These numbers only include the meteoroids large enough to produce detectable flashes. The micrometeorites, particles smaller than a millimeter, are not included. There are millions of them, billions. They are too small to see, too small to track, too small to avoid. And for an astronaut conducting a spacewalk on the lunar surface, even a micrometeorite at orbital velocity is a projectile moving faster than any bullet ever fired on Earth. No spacesuit currently in existence is designed to withstand that kind of impact energy. The moon's lack of atmosphere means there is no warning system. On Earth, we can track large asteroids and predict their paths years in advance. We can see meteors burning in the atmosphere and calculate where they might land. On the moon, there is nothing between the meteoroid and the surface. No friction to slow it, no heat to reveal it, no sound to announce it. One moment, the surface is still. The next moment, there is a flash, a crater, and a plume of debris launched into the vacuum at high speed. The flashes the Artemis II crew saw were beautiful in a terrible way. Points of light erupting on a dark world, brief and bright and violent. And every one of them was a reminder that the moon is not a sanctuary, it is a shooting gallery. And anyone who goes there needs to understand what they are walking into. But the impact flashes on the surface were not the only mysterious lights the astronauts encountered near the moon. Apollo crews reported a completely different kind of flash. Not on the surface, inside their own eyes, behind their closed eyelids, in total darkness. And the explanation for those flashes is not just strange. It is a warning about what deep space does to the human body. That is where we go next. Into the dark, into the silence, into the light that comes from inside. Chapter 9. The lights in their eyes. It started on Apollo 11. Buzz Aldrin was the first to report it. He was floating in the command module in the dark with his eyes closed, trying to sleep, when he saw a flash of light. Not through the window, not from a warning indicator, inside his eye. A brief streak of white light that appeared and vanished in less than a second. He opened his eyes. The cabin was dark. Nothing had changed. He closed his eyes again. Another flash. Every subsequent Apollo crew reported the same phenomenon. Apollo 12, Apollo 13, Apollo 14 through 17. Every astronaut who traveled beyond Earth orbit and spent time in darkness saw the flashes. They came in three shapes. Some were spots, brief pinpoints of light like a camera flash going off behind the eyelid. Some were stars, slightly larger, slightly longer lasting. And some were streaks, lines of light that traced across the visual field and disappeared. Most were described as white or colorless. But Apollo 14 astronaut Edgar Mitchell reported one that was different. He described it as blue with a white cast, like a blue diamond. The flashes came at irregular intervals. On average, Apollo astronauts reported seeing one flash every 2.9 minutes during dark adapted observation sessions. The phenomenon was more frequent during the outbound leg of the journey, the trans-lunar coast, than during the return trip. The astronauts were not hallucinating. They were not dreaming. They were being shot. The explanation is cosmic rays, high-energy charged particles that originate from some of the most violent events in the universe. Supernovae, black holes, the shock waves of colliding galaxies. These particles, mostly protons and atomic nuclei, are accelerated to velocities approaching the speed of light and then flung across the cosmos. They travel for millions of years across unimaginable distances, and some of them end up passing through our solar system. On Earth, we are largely protected from cosmic rays by two shields. The first is the magnetosphere, the magnetic field generated by the Earth's molten iron core. This field extends thousands of miles into space and deflects the majority of incoming charged particles, funneling them toward the poles where they produce the aurora borealis and aurora australis. The second shield is the atmosphere itself, which absorbs most of the cosmic rays that make it past the magnetic field. But the Moon sits outside the Earth's magnetosphere for most of its orbit. And the Moon has no global magnetic field of its own, no atmosphere, no protection. The Artemis II crew, traveling between Earth and the Moon, passed through the Van Allen radiation belts, regions of trapped charged particles surrounding Earth, and then entered the unshielded environment of deep space. Out there, cosmic rays pass through everything. They pass through the walls of the spacecraft. They pass through the astronauts' bodies. And some of them pass through their eyes. The leading explanation for the light flashes involves three possible mechanisms. The first is Cherenkov radiation. When a charged particle travels through a medium faster than the speed of light in that medium, it produces a brief flash of bluish light. Light travels slower through the vitreous humor of the eye than it does through vacuum. A cosmic ray particle moving at near light speed through the eyeball can exceed the local speed of light inside the vitreous humor and produce a visible flash. This is the same phenomenon that causes the eerie blue glow in the water around nuclear reactors. The second mechanism is direct ionization of retinal cells. The cosmic ray particle passes through the retina and deposits enough energy to trigger the photoreceptor cells, causing them to fire as if they had been struck by light. The brain interprets the signal as a flash. The third mechanism involves direct interaction with the optic nerve or even the visual cortex of the brain. Cosmic rays that pass through the skull and interact with the neural tissue responsible for processing vision could produce the sensation of light without ever touching the eye itself. During Apollo 16 and 17, NASA tested the phenomenon directly. They created a device called ALFMED, the Apollo Light Flash Moving Emulsion Detector. It was essentially a helmet containing a stack of photographic emulsion plates that would record the tracks of cosmic ray particles passing through it. The astronaut wore the helmet and reported flashes while the emulsion recorded particle tracks. The results were suggestive but limited. 2 out of 15 recorded particle tracks coincided with flash reports from the astronaut. The correlation was not strong enough to be conclusive, but it was consistent with the cosmic ray hypothesis. Astronauts on the International Space Station have also reported the flashes, though less frequently than Apollo crews. The ISS orbits within the magnetosphere for most of its trajectory, so the cosmic ray flux is significantly lower than in deep space. But during passes over the South Atlantic anomaly, a region where the Van Allen belts dip closer to Earth's surface, the flash rate increases. ISS astronaut Jerry Lininger reported that the flashes were directional during solar storms, coming predominantly from one side, and that they interfered with his ability to sleep. For the Artemis II crew, the cosmic ray environment was significantly more intense than anything an ISS astronaut experiences. A January 2026 article in the journal Science detailed the deep space radiation challenges awaiting Artemis astronauts. Beyond Earth's magnetosphere, the crew faced multiple radiation threats simultaneously. The Van Allen belts during transit, solar particle events, sudden bursts of high-energy particles from the sun that can spike to dangerous levels within hours, and the constant background drizzle of galactic cosmic rays, particles from outside our solar system that arrive at all times, from all directions, and cannot be avoided. The health consequences of this exposure are not fully understood, but there are troubling indicators. Studies of Apollo astronauts have shown that they were significantly more likely to develop cardiovascular disease than astronauts who never left low Earth orbit. The sample size is small. Only 24 humans have ever flown beyond Earth orbit, all of them Apollo astronauts, and all of them male. The Artemis II crew is the first to join that group in over 50 years. Koch is the first woman. Glover is the first black astronaut. Hansen is the first non-American. The long-term health effects of their 10-day exposure to deep space radiation will be monitored for years. But the effects go beyond cardiovascular disease. Cosmic rays damage DNA. They break molecular bonds. They cause mutations. And in the brain, where neurons do not regenerate the way other cells do, the damage accumulates. Studies on mice exposed to simulated galactic cosmic ray environments have shown cognitive decline, increased anxiety, and impaired memory. The relevance to humans is still being studied, but the implications for long-duration missions are serious. Artemis II lasted 10 days. A Mars mission would last 2 to 3 years. The astronauts would be bathed in cosmic rays for the entire journey, with no magnetic field to shield them and no thick atmosphere to absorb the particles. The flashes in their eyes are not just a curiosity, they are a symptom, a visible, perceptible symptom of invisible damage. Every flash represents a cosmic ray particle passing through the astronaut's head at nearly the speed of light, depositing energy, breaking bonds, and moving on. The astronauts can see the damage happening in real time. They just cannot stop it. The cosmic rays that shoot through astronauts' eyes are one piece of a larger puzzle about the moon's relationship with the most energetic particles in the universe. And the next chapter reveals that the moon itself has been keeping a record of those particles, not in its body, but on its skin. Written in magnetic ink that scientists have only recently learned to read. Chapter 10. The Magnetic Tattoos. One of the 35 targets the Artemis II crew observed during the flyby was a feature that has baffled scientists since the Renaissance. It is called Rhina Gamma. It sits in Oceanus Procellarum, the largest of the dark lava plains on the near side, and it looks like nothing else on the Moon. Rhina Gamma is a bright tadpole-shaped marking on the surface. It was first spotted through primitive telescopes in the 1600s and has been studied, debated, and argued over ever since. It is not a crater. It is not a lava flow. It is not a deposit of different material. It is a swirl, a pattern of brightness on the surface that has no obvious geological origin. It looks almost like someone painted a pale brushstroke across the dark mare basalt. The Artemis II crew flew over Rhina Gamma during the near-side approach phase of the flyby. They observed it from an angle and under illumination conditions that no satellite image had captured in exactly the same way. And while the crew's descriptions of the swirl will be analyzed for months, the deeper mystery of Rhina Gamma goes far beyond what any single flyby can answer. Because Rhina Gamma is not just a bright spot. It sits directly on top of one of the strongest magnetic anomalies on the Moon. This is where the story gets strange. The Moon has no global magnetic field. Not anymore. Earth has one. It is generated by the churning of molten iron in Earth's outer core, a process called the geodynamo. That magnetic field wraps around the planet, deflects solar wind particles, shields us from cosmic rays, and makes compasses point north. The Moon once had a similar field. Billions of years ago, the Moon's interior was hot enough and fluid enough to sustain a magnetic dynamo. But as the Moon cooled and its core solidified, the dynamo died. The global field collapsed. The Moon became magnetically naked. Except it is not entirely naked. Scattered across the lunar surface are dozens of localized magnetic patches, small regions where the surface rocks retain a magnetic signature, like a tattoo left behind by a field that no longer exists. These magnetic anomalies are weak by terrestrial standards, typically a few hundred nanotesla compared to Earth's field of about 50,000 nanotesla. But they are there, and many of the Moon's bright swirls, including Rhina Gamma, sit directly on top of them. The leading theory for how the swirls form is elegant and counterintuitive. It is called the magnetic sunscreen hypothesis. Here is how it works. The sun constantly blows a stream of charged particles outward through the solar system. This stream is called the solar wind. On Earth, the magnetosphere deflects most of these particles. On the Moon, which has no global field, the solar wind hits the surface directly. Over millions of years, this bombardment changes the surface material. It darkens it. It alters the chemical bonds. It shifts the reflectance properties. This process is called space weathering, and it is why the Moon's surface is generally dark and grey. But where a localized magnetic anomaly exists, the field, even though it is weak, can deflect some of the incoming solar wind particles. The surface beneath the magnetic patch receives less bombardment, less space weathering, less darkening. It stays brighter. The result is a visible bright marking on the surface that corresponds to the shape and extent of the underlying magnetic field. A 2018 study, published in Communications Physics, tested this idea with computer simulations and found that the magnetic field around Rhina Gamma is the right shape and strength to reproduce the observed swirl pattern. The model works. The magnetic sunscreen hypothesis explains Rhina Gamma, but it does not explain everything. Not every magnetic anomaly on the Moon produces a visible swirl. The magnetic field has to be the right strength and configuration. Too weak, and it does not deflect enough solar wind to make a difference. Too strong, and the pattern does not match the observed features. And the deeper question remains: where did these magnetic anomalies come from in the first place? The global field has been dead for billions of years. What magnetized these specific patches of rock? Three competing explanations have been proposed. The first suggests that cometary impacts deposited magnetized material onto the surface. When a comet strikes the Moon, it delivers its own material, and some comets contain iron-bearing minerals that could carry a magnetic signature. The impact itself could also generate intense local magnetic fields through plasma interactions. The second explanation involves basin-forming impacts. When a massive asteroid hits the Moon hard enough to excavate one of the giant basins, it launches iron-rich ejecta across the surface. If this material was heated above its Curie temperature and then cooled in the presence of the Moon's ancient magnetic field, it would lock in a permanent magnetic signature. The magnetic anomalies would be fossils, records of impacts that occurred while the Moon's dynamo was still active. The third explanation is the most recent and possibly the most compelling. A 2024 study, published in the Journal of Geophysical Research Planets by Liang and Krovchinsky, showed that high titanium magma cooling underground can produce strong enough magnetism to explain the observed anomalies. When magma rich in titanium-bearing minerals crystallizes slowly beneath the surface, the iron titanium oxide minerals that form can carry an intense magnetic signature, especially if the crystallization occurred while the Moon's ancient field was still active. The magnetic anomalies in this model are not surface deposits. They are underground magnets, buried deep in the crust, projecting their fields upward through miles of rock. In February of 2026, researchers from Oxford published findings that helped settle a decades-long debate about the Moon's magnetic field history. Previous studies had produced contradictory results about when the lunar dynamo operated, how strong it was, and when it died. The Oxford team showed that both sides of the debate were partially correct. The field existed in multiple phases, operating at different intensities at different times, before finally dying out approximately 1 billion years ago. The magnetic tattoos on the Moon's surface are records of that complex magnetic history, written in iron and frozen in time. NASA had planned a dedicated mission to investigate Reiner Gamma up close. The Lunar Vertex mission was originally scheduled for 2024 and would have sent a lander and a small rover directly into the swirl to take the first surface-level magnetic measurements. The mission has been rescheduled but remains a priority. Until a magnetometer is placed directly on the surface of a lunar swirl, the exact nature and origin of these magnetic anomalies will remain uncertain. The Artemis II crew saw Reiner Gamma from 4,000 miles above. They photographed it, they described it, but they could not solve it. The swirl remains one of the Moon's most beautiful and frustrating mysteries, a bright brushstroke on a dark canvas. A tattoo from a field that no longer exists. A message written in magnetic ink by a process that scientists are still learning to read. But the magnetic mysteries of the Moon's surface are just the beginning, because the biggest geological feature the Artemis II crew flew over is not a swirl, it is a hole, a basin so vast it is visible from Earth with the naked eye. And what lies at the bottom of it may hold the key to understanding not just the Moon, but the formation of the entire solar system. Chapter 11. The Basin at the Bottom of the World. The Orientale Basin was the primary geological target of the Artemis II flyby, and the crew did not disappoint. Orientale is a nearly 600-mile-wide impact crater that straddles the boundary between the near and far sides of the Moon. It was formed approximately 3.8 billion years ago when a massive object struck the lunar surface with enough energy to send shockwaves rippling outward in concentric rings, like the rings you see when you drop a stone into still water. Those rings are still there, preserved in rock. 3 enormous circular mountain ranges nested inside one another, the Cordillera Mountains on the outside, the outer Rook Mountains in the middle, and the inner Rook Mountains closest to the center. The basin floor between the rings has been partially flooded by lava, but the ring structures remain the most dramatic, intact impact feature on the near side of the Moon. As Orion approached and then passed Orientale, the crew observed it from continuously changing angles. This parallax effect gave them a three-dimensional sense of the basin's structure that no single orbital photograph can provide. Reid Wiseman reported seeing brownish tones in the outer rings. Victor Glover described the same features differently, perceiving slightly different colors. This discrepancy was not a problem. It was exactly the kind of data NASA wanted. Different observers perceiving different color nuances from different angles under different lighting conditions, all of it feeding into a richer picture of the basin's mineral composition than any satellite could assemble. Oriental is scientifically important because it is the youngest large basin on the near side of the Moon. It is the best preserved example of what happens when an enormous asteroid hits a world with no atmosphere, no water, and no plate tectonics to erase the evidence. By studying Oriental's ring structures, scientists can reconstruct the physics of giant impacts, how the shock wave propagated, how the crust fractured and rebounded, how molten material flowed into the basin, how the rings formed and stabilized. Everything we know about large-scale impact mechanics on rocky bodies draws heavily on Orientale. Northwest of Orientale, on the far side, the crew observed Hertzsprung crater. Hertzsprung is nearly 400 miles wide and significantly older than Oriental. Where Oriental's rings are sharp and dramatic, Hertzsprungs have been battered and softened by billions of years of subsequent impacts. The contrast between the two basins is a visual time-lapse of geological aging on a world without weather. On Earth, a 4-billion-year-old impact crater would be long gone, erased by erosion, burial, and plate tectonics. On the Moon, the craters persist. They degrade slowly through the accumulation of smaller impacts, each one chipping away at the original structure. Hertzsprung shows what Orientale will look like in another billion years. But the most significant basin the crew glimpsed, even if only briefly, was not Orientale or Hertzsprung. It was the South Pole Aitken Basin, and it is one of the most extraordinary features in the entire solar system. The South Pole Aitken Basin, often abbreviated SPA, is a colossal impact structure on the far side of the Moon. It is approximately 1,550 miles across and 5 miles deep. To put that in human terms, it is wider than the distance from New York to Denver and deeper than any ocean trench on Earth. It is one of the largest known impact structures in the solar system, comparable in scale to the Hellas Basin on Mars and dwarfing anything on Earth. The SPA is so large that when the asteroid or comet that created it struck the Moon, it may have punched entirely through the crust and into the mantle below. The basin floor may contain exposed mantle material, rocks from deep inside the Moon that were blasted to the surface by the force of the impact. If scientists can get their hands on those rocks, they can learn about the composition of the Moon's interior, the thermal history of its mantle, and the conditions that existed in the inner solar system during the period of heavy bombardment roughly 4 billion years ago. China's Chang'e 6 mission did exactly that. In June of 2024, the robotic spacecraft landed inside the South Pole Aitken Basin and collected the first ever samples from the far side of the Moon. The samples were returned to Earth, and the results, published in the journal Nature in July of 2025 across 4 separate papers, were revelatory. The far side mantle, as revealed by the Chang'e 6 samples, is what scientists call extremely depleted in incompatible elements. These are elements that do not fit easily into the crystal structure of common minerals and tend to concentrate in liquid magma during melting processes. On the near side, incompatible elements are abundant, part of the creep signature that drives volcanic activity. On the far side, they are almost absent. The two hemispheres of the Moon are chemically distinct in ways that go far deeper than surface appearance. And the water data was perhaps the most consequential finding for future exploration. The far side samples contained less than 2 micrograms of water per gram of rock. The near side, by comparison, can contain up to 200 micrograms per gram. The far side is essentially bone dry. This was not entirely unexpected. since the far side lacked the volcanic outgassing that could have delivered water-bearing minerals to the surface. But the magnitude of the difference was striking. For mission planners, this dryness is a serious constraint. Water is the most critical resource for any long-term lunar presence. It is needed for life support, for growing food in greenhouses, and for manufacturing rocket propellant through electrolysis, splitting water molecules into hydrogen and oxygen. The oxygen is breathable, the hydrogen is fuel. Without water, a permanent base becomes entirely dependent on resupply from Earth, which is ruinously expensive. This is why the lunar South Pole has become the target for the next generation of missions. The South Pole contains permanently shadowed craters, regions where sunlight has not reached for billions of years. Temperatures in these craters can drop below -230 degrees Celsius, cold enough to trap and preserve water ice delivered by comets and asteroids over billions of years. Multiple spacecraft have detected signatures consistent with water ice in these shadows, including NASA's Lunar Reconnaissance Orbiter and India's Chandrayaan-1 mission. If the ice is there in usable quantities, it changes the economics of lunar exploration completely. Artemis III plans to land astronauts near the South Pole, in part to investigate these ice deposits. Artemis IV will build the Lunar Gateway space station in a near rectilinear halo orbit around the Moon, providing a staging point for surface missions. The long-term vision is a permanent human outpost, a base camp for science, for resource extraction, and for the eventual journey to Mars. The Artemis II crew only got a small glimpse of the lunar South Pole during their flyby. Their trajectory and the lighting conditions limited what they could see, but their observations of Orientale, Hertzsprung, and the far side terrain all feed into the geological picture that will guide the missions ahead. Every photograph, every verbal description, every color observation contributes to the map that future astronauts will use when they land. The crew's observation period was nearing its end, but the most spectacular sight of the entire mission was still ahead, because as Orion continued along its trajectory, the sun began to slip behind the Moon. And for the next 57 minutes, the Artemis II crew witnessed something no human being had ever seen before: a total solar eclipse from behind the Moon. An eclipse that lasted not minutes, but nearly an hour. Chapter 12. The eclipse that lasted an hour. On Earth, a total solar eclipse is one of the rarest and most powerful experiences a human being can have. It lasts minutes, sometimes less than 2. The Moon slides across the face of the Sun, the sky goes dark, the corona appears, and then it is over. People travel thousands of miles for those few minutes. They weep, they scream. They describe it as life-changing. Now take that experience and multiply it by 30. At 8:35 p.m. Eastern Time on April 6, 2026. From Orion's perspective, the Sun began sliding behind the Moon. The crew had been briefed. They had been prepared. They had eclipse glasses ready for the initial partial phase when the Sun's disk was still partially visible. For the first 2 minutes, they wore the glasses to protect their eyes from the blinding solar surface. Then, the Moon slid fully over the Sun. The disk disappeared, and the corona appeared. Reid Wiseman spoke first. "It is indescribable," he said. "No matter how long we look at this, our brains are not processing this image in front of us. It is absolutely spectacular, surreal. There are no adjectives. I need to invent some new ones." Victor Glover followed. "Humans probably have not evolved to see what we are seeing," he said. "It is truly hard to describe. It is amazing." On Earth, totality during a solar eclipse lasts a few minutes at most, because the Moon's shadow moves across the Earth's surface at roughly 1,000 miles per hour. You are standing in one spot and the shadow sweeps past you. From Orion's perspective, the geometry was completely different. The spacecraft was moving in the same general direction as the Moon relative to the Sun. The alignment held, and held and held. Totality lasted from 8:35 to 9:32 p.m. 57 minutes, nearly an hour of the sun's disk completely blocked by the moon, with the solar corona visible the entire time. The corona is the sun's outermost atmosphere. It extends millions of miles into space and is only visible during a total solar eclipse because the sun's surface is so overwhelmingly bright that it drowns out the faint corona under normal conditions. From Earth, the corona appears as a white halo around the black disk of the moon. From Orion, 4,000 miles above the lunar surface, the corona wrapped almost entirely around the moon. The crew described streamers, long structures of solar material, extending outward from the sun like filaments or tendrils. Glover compared them to baby hairs, fine, delicate, luminous threads radiating into the blackness. And then, Glover found the metaphor that captured it. If you have ever seen the spotlight off the top of the Luxor at night in Las Vegas, he said, this looks like what that wants to be when it grows up. The Luxor spotlight is a 42 billion candle power beam that shoots straight up from the top of the hotel pyramid, visible from space. Glover was saying that the solar corona made that beam look like a flashlight. During the eclipse, the crew made several additional observations. They spotted multiple planets: Venus, Mars, Saturn, Mercury, all visible as bright points against the darkened sky. Hansen noted that the sun was illuminating the entire perimeter of the moon during the eclipse, highlighting topographic features along the lunar edge from a unique angle. Glover reported that the crew also observed 2 meteors during the eclipse, not impact flashes on the moon's surface, but actual meteors streaking through space. These would have been tiny particles of debris burning briefly as they interacted with the diffuse solar environment, or simply reflecting sunlight as they passed through the field of view. The crew also searched for 2 additional phenomena during the eclipse. The first was zodiacal light, a faint glow caused by sunlight reflecting off interplanetary dust particles that fill the plane of the solar system. The second was lofted lunar dust, microscopic particles that are electrostatically levitated above the moon's surface by the sun's ultraviolet radiation. This phenomenon was first observed during the Apollo missions, when astronauts and unmanned spacecraft detected a mysterious glow along the lunar horizon at sunrise and sunset. The dust particles are charged by solar radiation and repelled from the surface, floating just above it in a thin cloud. During the eclipse, with the sun blocked, the conditions might have been right to observe these dust particles silhouetted against the faint coronal light. There had also been hopes that comet C-2026, A1 MAPS, might be visible during the eclipse. Comets near the sun can sometimes be spotted during totality because the corona provides just enough illumination to reveal their tails. But this particular comet did not survive its close approach to the sun on April 4th. It broke apart before the flyby, and then there was the Earthshine. This was perhaps the most unexpected observation of the entire eclipse. Wiseman said he did not anticipate just how much sunlight would still illuminate the moon from behind. The source was not the sun, it was Earth. The daytime side of our planet reflects sunlight outward into space. Some of that reflected light reaches the moon and illuminates its night side surface. This is the same faint glow you can see from Earth when you look at a crescent moon and can just barely make out the dark portion of the disk. From Orion's perspective, with the sun blocked and the crew's eyes adapted to the darkness, Earthshine was startlingly bright. Glover described it. "The Earth is so bright out there," he said, "and the moon is just hanging in front of us, this black orb." He reported that Earthshine was bright enough to see surface features on the night side of the moon. The light from our own planet was illuminating another world, clearly enough to make out detail from thousands of miles away. Think about that for a moment. The crew was watching our planet light up the moon, not the sun, Earth. The reflected glow of 7 billion people's home was painting the lunar surface in a faint blue-white wash, visible to the naked eye from 250,000 miles away. It was as if the Earth was saying, "I am still here. I am still bright. Even from this far away, you can see me." The eclipse ended at 9:32 p.m. The sun began to reappear from behind the moon. The crew put their eclipse glasses back on. Kelsey Young radioed up, one final time from the science evaluation room. "I cannot say enough how much science we have already learned," she said. "You really brought the moon closer for us today." The observation period was over. The flyby was complete. The crew began preparing for the 4-day journey home. But one more message came through that captured the spirit of the entire day. Capsule communicator Jenny Gibbons told the crew that all the flight controllers in Houston had flipped their Artemis II mission patches around. On one side, the patch showed the Artemis II logo with Earth in the foreground and the moon in the distance. The controllers turned them over, moon in front, Earth behind. "We are earthbound," Gibbons said, "and ready to bring you home." The perspective had shifted. The moon was no longer the destination. It was the vantage point, and the crew was heading back to the small, bright planet that had been lighting up the darkness the entire time. Chapter 13. Jim Lovell's Neighborhood. Jim Lovell flew to the moon twice. The first time, on Apollo 8 in December of 1968, he and his crewmates, Frank Borman and Bill Anders, became the first human beings to leave Earth orbit, travel to another world, and see the far side of the moon with their own eyes. It was Christmas Eve. They orbited 10 times. They read from the Book of Genesis during a live television broadcast. Bill Anders took the Earthrise photograph. The mission lasted 6 days. The second time, on Apollo 13, in April of 1970, Lovell commanded a crew that nearly died. An oxygen tank exploded 2 days into the mission, crippling the spacecraft. The crew used the lunar module as a lifeboat. They swung around the far side of the moon, using its gravity to fling them back toward Earth. During that swing, they set the record for the farthest distance any human had traveled from home. 248,655 miles. They made it back alive. Barely. Jim Lovell lived another 55 years after that. He watched the space shuttle program. He watched the International Space Station being built. He watched Mars rovers send back photographs. He watched the Artemis program take shape. And 2 months before his death in August of 2025 at the age of 97, he sat down and recorded a message for the crew that would finally break his record. "Hello, Artemis II," he said. "This is Apollo astronaut Jim Lovell. Welcome to my old neighborhood. It is a historic day, and I know how busy you will be, but do not forget to enjoy the view." Mission Control beamed the recording up to Orion on the morning of the flyby. The crew listened to the voice of a man who had circled the moon at Christmas and nearly died trying to get home. A man who had seen the far side, experienced the blackout, watched Earthrise, and carried those memories for more than half a century. A man who understood better than almost anyone alive what the Artemis II crew was about to go through, and who wanted them to know, above all else, to enjoy it. The crew carried Lovell's Apollo 8 silk mission patch aboard Orion. The same patch that had flown to the moon in 1968 was now flying to the moon again in 2026. Wiseman held it up during the flyby. "It is just a real honor to have that on board with us," he said. "Let us go have a great day." The connection between Apollo and Artemis is not just symbolic, it is structural. Artemis II flew the same free return trajectory as Apollo 13, using the moon's gravity to swing around the far side and slingshot back toward Earth. The same physics, the same path through space. But unlike Apollo 13, there was no emergency. The spacecraft was healthy. The crew was prepared. The mission was proceeding exactly as planned. This time, the view was the point. But the crew was not the same as Apollo's, and that difference matters. Christina Koch became the first woman in history to travel beyond Earth orbit. She already held the record for the longest single spaceflight by a woman, 328 days aboard the International Space Station. Now, she had added another first. Koch described the mission in one word: humility. Victor Glover became the first black astronaut on a lunar mission. He had previously served as pilot on the SpaceX Crew Dragon mission to the ISS. During the flyby, Glover delivered an impromptu message that captured the overview effect in its purest form. "Trust us," he said. "You look amazing. You look beautiful. You also look like one thing. Homo sapiens is all of us, no matter where you are from or what you look like. We are all one people." Jeremy Hansen became the first non-American to fly to the moon. A Canadian Space Agency astronaut and former fighter pilot, Hansen brought a quiet intensity to the mission that emerged most powerfully during the Carroll Crater naming. But it was his words, "At the moment, the crew broke the Apollo 13 distance record," that set the tone for the entire enterprise. "We most importantly choose this moment," he said, "to challenge this generation and the next to make sure this record is not long-lived." That sentence deserves to be heard twice. He did not celebrate the record. He challenged the future to break it. The record exists to be broken. Artemis III will land humans on the moon. Artemis IV will build a space station in lunar orbit. The goal is not to visit, it is to stay. And eventually, it is to go further. Mars, the asteroids, the outer solar system. Hansen was not commemorating an achievement. He was issuing an invitation. The Artemis II crew represents something that Apollo never did. Apollo was extraordinary, but it was narrow. All Apollo astronauts were American. All were male. All were military test pilots. The brilliance of what they accomplished is beyond question. But the demographic uniformity of the program reflected the era in which it was born. Artemis is different. A woman, a black man, a Canadian, and an American commander who lost his wife and raises his daughters alone. The crew looks more like the world than any previous deep space mission. Glover put it best. "We call amazing things that humans do moonshots for a reason," he said. "Because this brought us together and showed us what we can do when we not just put our differences aside, when we bring our differences together." At 2,756 miles from Earth, 4,111 miles beyond Apollo 13's record, the Artemis II crew became the humans who had traveled farthest from home. They did it together. They wept together. They ate maple cream cookies together behind the moon. They named a crater after a woman who could not be there, and they began the journey home. The splashdown is scheduled for April 10th in the Pacific Ocean off the coast of San Diego. The crew will be recovered by the USS John P. Mercer. They will undergo medical evaluations. They will be flown to Johnson Space Center in Houston. They will debrief. They will share their data. And then they will try to describe what they saw. They will fail. Not because they lack eloquence, because the experience exceeds language. Wiseman said it himself. "There are no adjectives. I need to invent some new ones." Glover said, "Humans probably have not evolved to see what we are seeing." Koch said, "Humility." Hansen said, "Make sure this record is not long-lived." And Lovell, from beyond the grave, said it simplest of all, "Do not forget to enjoy the view." Chapter 14. Do not forget to enjoy the view. The moon is 238,900 miles away on average. It takes light a little more than a second to get there. It takes a spacecraft about 4 days. It takes a lifetime of training and a decade of engineering, and the combined effort of tens of thousands of people to send 4 human beings on the journey. And when they arrive, when they float above it in a capsule the size of a large closet and look down at a world that has been silent for 4.5 billion years, they see something they were not prepared for. They see how fragile everything is. Not the moon. The moon is fine. The moon has been fine for longer than life has existed on Earth. It will be fine long after every human city has crumbled to dust. The moon does not care about us. It sits in its orbit, tidally locked, one face always turned toward us, one face always turned away, absorbing meteoroid impacts by the millions, grinding them into its surface, wearing the scars of 4.5 billion years of cosmic violence without complaint. The moon is patient in a way that nothing human can comprehend. What is fragile is us, our planet, our presence. The thin membrane of air and water and life that wraps around a small rock, orbiting an average star in a galaxy of 400 billion stars in a universe of 2 trillion galaxies. From the surface, that membrane feels infinite. From the moon, it does not. From the moon, it looks like what it is: a film, a breath, a blue mist clinging to a rock. Every astronaut who has ever seen Earth from space says the same thing. The borders disappear. The conflicts shrink. The arguments that consume our days down here become invisible from out there. What remains is the planet itself, blue and white and impossibly bright against the black. The only home, the only one. Glover saw it and said, "You look like one thing." Koch saw it and said, "Humility." Wiseman saw it and searched for adjectives and found none. Hansen saw it and challenged the future to go further. The Artemis II mission lasted 10 days. The flyby lasted 7 hours. The eclipse lasted 57 minutes. The blackout lasted 40. The Carol moment lasted maybe 2. And yet those moments contained more wonder, more grief, more beauty, and more truth than most people encounter in a year, because space does that. It compresses experience. It strips away the noise. It forces you to confront what matters by removing everything that does not. The crew saw 6 impact flashes on the moon. 6 rocks from deep space detonating on a world with no defense. They saw the far side, battered and ancient, a hemisphere of craters that has been hiding in plain sight for the entire history of human civilization. They saw the 2-faced moon, one side shaped by radioactive fire, the other left cold and barren by a chemical coin flip that occurred before life existed on Earth. They saw Earthrise. They saw the Terminator. They saw mountain peaks so bright they looked like snow. They saw the corona of the sun wrap around the moon like a crown of white fire. They saw Earthshine paint the nightside surface with the reflected glow of their home planet. And they saw each other cry. The data from Artemis II will be analyzed for months. The crew's photographs, verbal descriptions, and color observations will be compared with satellite imagery and ground-based monitoring data. The impact flash reports will be cross-referenced with citizen science observations. The magnetic anomalies will be studied. The far-side geology will be debated. The water data will inform the design of future missions. The science is real and it matters. But the science is not the only thing that matters. What matters is that 4 people from different backgrounds, different countries, different life experiences went to the moon together and came back changed. What matters is that a man named a crater after his dead wife, and the whole world stopped to listen. What matters is that a 97-year-old astronaut who had seen the far side 58 years earlier recorded a message for the next crew and told them not to forget to enjoy the view. What matters is that a woman became the first to fly beyond Earth orbit and describe the entire experience with a single word: humility. What matters is that we went back. For 53 years, the moon sat there, waiting. No human had visited since 1972. We built space stations. We launched telescopes. We sent rovers to Mars. But we did not go back to the moon. An entire generation was born, grew up, grew old, and never saw a human being travel beyond low Earth orbit. The moon became a memory. A place we had been once, briefly, and then abandoned. Artemis II ends that abandonment, not with a landing, that comes later, but with a return, with human eyes on the lunar surface again. with human voices describing what they see, with human tears floating in microgravity beside a window that frames a world no photograph can fully capture. The next missions will go further. Artemis II will land near the South Pole. Astronauts will walk on the Moon for the first time in more than half a century. They will search for water ice in permanently shadowed craters. They will drill into the regolith. They will set up instruments and collect samples and stay for days instead of hours. Artemis IV will build the lunar gateway. And beyond that, the long road to Mars. Each step requires what came before. Artemis II proved that the Orion spacecraft can carry humans to the Moon and bring them home safely. It proved that the Deep Space Network can track them. It proved that Mission Control can manage the blackout. It proved that the heat shield can survive re-entry. And it proved something no engineering test can measure. It proved that the experience of going to the Moon still has the power to change the people who do it and the people who watch. In the quiet hours after the flyby, as Orion began its 4-day coast back to Earth, the crew floated in their cabin and looked out the window. The Moon was behind them now, shrinking. The sun was ahead, and Earth was growing brighter with every hour. The mission patches in Houston had been flipped. Moon in front, Earth behind, Earthbound, ready to bring them home. Somewhere in the darkness behind them, a crater called Carroll caught the sun's light and glowed. If you enjoyed this deep journey through science, space, and the mysteries of our Moon, please like this video and subscribe to the channel. Your support makes these detailed stories possible. Tell us in the comments what surprised you most about what Artemis II saw, and what should we investigate next. These are not just questions for scientists, they are questions for all of us. Because the Moon is not just a destination, it is a mirror. And what we see when we look at it depends on who we are when we look. Thank you for listening. We will see you in the next investigation.